Good afternoon, all of my geometry students and all the other geometry students here watching this video. We are reviewing for Section 6 exam. Please note that this is a very long test. This review looks a lot like the test, but it is missing your two-column proof as well as problems where we compare triangles looking for congruency using the postulates. So let's go ahead and get started. As you can see, if you have an old version of the review, make sure that your triangles you're being asked for match the ones on my paper. We'll go ahead and get started. FDB, you can see, is we have two sides that are congruent with an obtuse angle here. So this would be an obtuse isosceles. FAB, if I turn the paper, you can see FAB has two congruent sides and an acute angle at the top. That would be an acute isosceles. Acute isosceles. BCD. BCD has three congruent sides. BCD would be an equilateral. FDE, it has two congruent sides and a right angle in the middle, so that would be a right isosceles. Isosceles means that you have two congruent sides. Scalene has no sides that are congruent. Moving on, please consider the triangle here. Determine the measure of each interior angle and classify the triangle. So we know that the interior angles of a triangle sum to 180. So we need to add up all of the angles and set it equal to 180. Okay, this is where we'll go ahead and combine like terms. 3x, 2x, and 3x is 8x. And then our constants, 68 and 20 is 88. 88 minus 4 is 84, equals 180. Subtract 84, subtract 84, we get 8x equals 96. Divide by 8, divide by 8, x equals 12. Awesome. That's our first step in understanding or solving the problem. So now we need to find the measure of m. Well, we are going to plug 12 into x to find each angle. So I have 2 times 12, so times, plus 68. 2 times 12 is 24, plus 68 is 80, 92 degrees. Awesome. Okay, moving on, I'm going to take what our x equals and plug it into here. So I have 3 times 12 plus 20. So 3 times 12 is 36, plus 20 is 56. And our angle N would be 3 times 12 minus 4. That's 36 minus 4 is 32. Okay, so what type of triangle is this? Well, if our largest angle is greater than, this is our largest angle, it's 96, right? It's greater than, 92, is greater than 90, then we have an obtuse triangle, because this one was 90, this right here equaled 32, and this one equaled 56. Lots of colors going on. Okay, next, Eleanor's Flag Company is producing flags to sell at the Fall Craft Show. Each flag is in the shape of an isosceles triangle. To give the fabric support, a ribbon needs to be sewn around the outside edges of the flag. The base of each triangle is 1.5 feet. Eleanor has ordered 600 feet of ribbon and is hoping to make at least 50 flags. What is the maximum length possible for each leg of the triangles? Okay, well, we have 600 feet of ribbon to use for our 50 flags. So if I have 600 feet total to use for 50 flags, I need to know how much I get to use for one flag. So I would take 600 feet and divide it by 50 flags. And that means that I would have 60 divided by 5 is 12 feet per one flag. Per one flag. Okay, so I have 12 feet. So I have 12 feet to make it around one flag. And they tell us that one side, or the base, is 1.5 feet. So if I have 12 feet to go around the whole flag, and the base is 1.5 feet, that means I have 12 minus 1.5, or 10.5 feet to share for both sides. Since it's an isosceles triangle, I know that these sides are congruent, which means I need to divide 10.5 by 2, giving me 5.25 feet. And that's your final answer. And you could check it, because if this was 5.25 and this is 5.25 and you add 1.5, that gives you 12. And if you multiply 12 by 50 flags, that would give you 600 feet. Consider the right triangle to the left. If the perimeter of the triangle is 500 centimeters, find the value of x and the area of the triangle. So x equals blank and the area of the triangle is blank. Okay. This is a perimeter question. It says the perimeter is 500 centimeters. They give us the lengths of the three sides of our triangle, so I only have to set them equal to my perimeter. 500. All right, we'll go ahead and combine like terms again. 7x, x, and 4x. So 7 and 1 is 8. 8 plus 4x is 12x. And then I'm going to combine the constants. I have negative 60, negative 10, which is negative 70. But if I add back 6, I have negative 64, which is equal to 500. I'm going to add 64 and add 64. I get 12x equals 564. So I'm going to move this up here. 12x equals 564. Divide by 12, divide by 12, and x equals, so turn my calculator on, clear it out. Hopefully you guys can see this. It's 564 divided by 12. We have 47. All right, so x equals 47. Okay, so if, let's see, we're asked to find x, so 47 is that answer there, and the area of the triangle is blank. Okay, so this is our triangle here, and if you remember, we know that the area of a triangle is 1/2 base times height, or base times height over 2, and of course that comes from knowing that if we have a rectangle or a square and we were to find the area, it'd be base times height. Oop, that's base times height, and it's half of your base times height, right? It's half of the rectangle. So we know what we have to do. So we have area again is 1/2 base times height. Okay, our base would be 4x plus 6, so we need to plug in the 47. So it's going to be 4 times 47 plus 6, and then 47 minus 10. Okay, I need a calculator for that. So 4 times 47 plus 6 is 194. And then 47 minus 10 is 37. So my base equals 194. So area is equal to 1/2 base is 194 times 37. Awesome. So 194 times 37, 194 times 37 equals 7,178 divided by 2, is 3,589. 3,589, that's a comma, not a period. So 3,589. Okay. Moving right along. Calculate the area of the triangle ABC with altitude BD. Okay, again, this was a typo on the original. It should say BD, not CD. Make sure that your paper says BD. Also, I've put in a couple graphs here just to help me show you guys what this looks like. Yours do not have both graphs. So, calculate the area. So I just need to plot this. I have 1, 2, 3, 4, 5, up 2, 3, 3, and 1, -7. I'm going to pull out my ruler. Okay. And you might ask why there are 4 points when there are only supposed to be 3 vertices of a triangle, and that's because your altitude will be found by using D. So D is -3, -1. This will be D, but we're not going to use that quite yet. We need to find the perimeter first. And how do we find the perimeter? Well, we have to find all the lengths, or the 3 lengths of the sides of the triangle. And I'm going to do that by making right triangles. So you could use the distance formula, and that's absolutely fine. Distance formula is derived from the Pythagorean theorem, or you can also draw right triangles, which I prefer. Less opportunity for mistakes. So draw this in. Okay, and we just calculate away. So here we go. This one is a 1 by 1, 2, 3, 4, 5, 6, 7, 8, a 1 by 8. So this slant here is going to be 1 squared plus 8 squared equals c squared. 1 plus 64 equals c squared. 65 equals c squared. Take the square root of both sides. And this here is the square root of 65, which is equal to, and this is really important that you make sure that when you find the square root, so let's see here. So I'm going to clear this out. I'm going to take this second button, and I'm going to hit this square root sign. Oops. One more time so you guys can see. Clear this out. I'm going to take the second button, and then the square root sign, which is right here. It's a squared sign. I get my radical, and I'm going to put 65 in and hit enter. It's very important that you keep all of these digits. Very, very important. So I'm going to go ahead and write this out. It's 8.06, and I'm going to go out 4 places so I don't make any mistakes on rounding. Okay. 1, 2, 3, 4, 5, 6, 7, 8, 9. This is 9. I'm finding this distance here. So this is 9 by 1, 2, 3, 4, 5, 6. 9 by 6. 9 squared plus 6 squared equals c squared. I have 81 plus 36 equals c squared. 81 plus 36 is 117 equals c squared. Take the square root of both sides, and c is equal to the square root of 117. So this diagonal here is the square root of 117, which is equal to square root of 117 equals 10 point, all right, we got to write that whole thing down, 10.816, and it says 665, so I'm going to have to go 67. Okay, here we go. Last one. So I have a 2 here by, let's see, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10. Okay, so our slant here is going to be 2 squared plus 10 squared equals c squared. This is 4 plus 100 equals c squared. This is 104 equals c squared. Take the square root of both sides. So I'm going to turn it this way. This length is going to be the square root of 104, which equals, again, the square root of 104 is equal to 10.1980. Okay. Woo! So now I have to add all of those up. So I'm going to add up 10.8167 because it's a perimeter, 8.0623, and 10.1980 when you add them all together. So adding them up, all right, I have them all in my calculator, and I get 29.07695. Lots of numbers. Okay, but it says to the perimeter. All right, and we want to round our answer to the nearest tenth if necessary. So that means this is 29.1, right? This rounds to 29.1. Okay, you want to be very careful about rounding. Do not round too early. You will lose information and not get the right answer. Now we need to find the area. Okay. So again, I'm going to regraph this. 1, 2, 3, 4, 5, up 2. There's our A. Our B is 3, 3. Our C is 1, -7. And our D is -3, -3, -1. We're here. Oh, and yep, there we go. So I'm going to connect my dots. And again, our D, which was given, they told us that the altitude, so this was A, B, C, and D, and it says our altitude, right here, our altitude, BD. So BD, okay, so that means that this, BD, is the height of our triangle. This is the base, and this is the height. This must also be perpendicular, and you could test it by finding the slope. The slope here of the base would be down, let's see, down 1, 2, 3 over 2, and this slope is up 1, 2 over 3. 1, 2, 3. Awesome. Just a sec. Okay. My computer decided to lock. All right, so here we go. So I already have the length here, so I already know that this base is the square root of 117, which is also equal to 10.8167. I already calculated that, but now I need to find the height, the length of this height here. And again, you can use the distance formula, or I can make a right triangle out of it, which I'm going to do. So this is going to be up and over, and that's why I did this on two separate graphs, so you can see. So the height, so maybe I should color it in, this triangle right here, right, is the height of our triangle, right? But I need a right triangle, so this is 1, 2, 3, 4. So this is 4 by 1, 2, 3, 4, 5, 6. So I have 4 squared plus, here we go, 4 squared plus 6 squared equals c squared. Not trying to make you dizzy. This is 16 plus 36 equals c squared. That's 52 equals c squared, square root, and we have this, our height is the square root of 52, okay, which also, the square root of 52, clear, the square root of 52 equals 7.2111. Okay, that equals C. So don't forget, so we need our area. Our area is 1/2 base times height, or base times height over 2, right? And so our area equals, our base is 117, and our height is the square root of 52 all over 2. And I like to leave it in the square root, or in the radical form, just in case. 117 times 52 equals a perfect square, and it actually does. So the area is equal to the square root. Remember, these are just the factors. You can also multiply them back together, and it's 6084 over 2, which is equal to, well, what's the square root of 6084? Well, the square root of 6084 is 78. A lot of glare. Let's see. Is 78. Maybe that's better with the light off. So the area is 78 over 2, which equals 36. Oh my goodness. And you would have gotten the same thing if you had taken the square root of 117 and multiplied by the square root of 52, but you would have had to make sure you didn't round at all. I really like keeping it together in the radical, multiplying it back, and checking to see if my multiplied radical is a perfect square. And it is. So I have 36 over 2, okay? And so this is area. This is my, 78 over 2, which is 36. So my area is 36 square units. No rounding necessary for that one. Okay. Okay, number 6. 21 minutes in. Here we go. So find the measures of the missing angles. And this one is all about the way that you orient the triangle. And I think it's easiest to see that if you turn the paper and maybe we cover up. So we turn the paper and then cover this little edge up. And you know that we're looking, so this is 58 degrees. We're looking for this angle here, and this looks like an isosceles triangle. So our measure of angle 1 must be 58. So 58 degrees. And the measure of 2, okay, so if this is 58 and this is 58, these are both 58, then we have our angle 2 must be 180. So angle 2 is 180 minus 58 minus 58, right? And so if you just take your calculator and you add 58 to 58 and you subtract it from 180, you get 64. So 64 degrees, okay? Go ahead and put 64 here. So now that we know that this is 64 degrees, we can move on. All right, so let's see where we at here. All right, so measure of, so we know this is 64, good. Now we have measure of 3. Well, if you remember from a previous section, 2 plus 3 must be, they're a linear pair, they must be supplementary, and so that means they must equal 180. So 180 minus 64, right, equals 116. Write this here. This is 180 minus 64. That equals 116. Okay, and the measure of 4 is our last one, so we know that measure of 3 is 116, right? And this is, it tells us this is 12 up here, so if we have 12, 116, and we're missing this last one here. So 4 must be 180 minus 116 minus 12, okay? So we have 180 minus 116 minus 12 is 52 degrees. And you can check that, so this should be 52. So 52, 116, and 12 better be 180, and 58, 58, and 64 must also be 180. Okay. The portable basketball hoop shown to the right is made so that BA, AS, and AK are all 10, so they're all equivalent. It says that BSK, okay, BSK, this angle here is 64. What is the measure of AK KB. So, oh goodness. So we're asking about this right here, right? This is our question mark, this angle right in here. Okay, well, what do we know? We know that we have, let's see, we have an isosceles triangle, so this must be 64 here, right? If this is 64 here, then we can solve for this. So this is 128. This one must be 180 minus 128. So 180 minus 128 is 52. I guess we knew this from before, right? So this is 52. If this is 52, this must be 180 minus 52. So 180 minus 52 would be 128. Okay? And then because this right here is an isosceles triangle, if this is 128 up here, then they must share their angles equally. So this would be 128 for right here, and these both are 180. So it's 180 minus 128. We already said we have, that's 180 minus 128. We already knew that, that's 52. So that's 52 here. So they must share 52. So this must be 52 divided by 2 equals 26. This must be 26, and this must be 26. Okay. I hope you can follow my sideways thing. 6 degrees. All right, on to the next one. So I have this little picture here. Looks kind of like a bow tie. And it says find the measure of B and E. That must be a typo. I think it says, it means we want A and B. Okay, here we go. So they really meant A and B. It just wasn't a change up here. So we have this shape, and it looks like we have, we're going to assume that these are equal. It tells you that these are equal, and we're going to assume that these two are equal, although not a lot of information. So assuming they're equal, we have 5x plus 34 is equal to negative 2 plus 14x. All right, and there are degree signs on here, but I'm not going to include that. So we just need to, looks like combine like terms. So I'm going to subtract 5x, subtract 5x. I get 34 is equal to negative 2 plus 9x. I'm going to add 2, and I get 36 equals 9x. Divide by 9, and x equals 4. So x equals 4. And then I'm plugging in to find a. So a is going to be 5 times 4 plus 34. So 5 times 4 is 20, and 20 and 34 is 54. And then I'm going to plug in here, so negative 2 plus 14 times 4. So 14 times 4 is 4 times 10 is 40, plus 16, so 56 minus 2 is 54. Okay. Find the measure of HKJ. Okay, so we're looking for this. All right, so let's see, what are we going to do? Well, we need to find x, and it feels like there's a little bit of missing information, but let's check this out. So we know 21 is up here. We're good with that. We have this is negative 4x minus 1. Okay. And then we have negative 10x plus 2. Let's see. All right. I think that on your version, these are both positive. Let's see if that works. Okay. So, yes. So I have here, so I know that the interior angles of a triangle equal 180. So this is 4x minus 1 here. And this is 21. But the question is, what is this interior angle? Because this is the exterior angle. Well, we know that these two are a linear pair. So this angle here would be 180. So this angle here, our third angle is 180 minus this angle here. And that angle just happens to be with an x and a parentheses. That's okay. So again, 21, 4x minus 1, we're missing this angle, but we know that this angle plus this angle equals 180, so 180 minus this part of the angle would give us the remainder. And that equals 180. So I'm going to clean this up. So let's see, I can subtract 180 off both sides. That makes it easy. I get 4x minus 1 plus 21 minus, and then I have 10x plus 2 equals 0. I need to distribute this negative to both of these terms inside. So 4x minus 1 plus 21 minus times 10x is minus 10x. Minus times positive 2 is minus 2 equals 0. And I get negative 6x. So I'm combining my 4x and my negative 10x. That's negative 6x. And I have 21 minus 2 minus 1. And so it looks like 21 minus 1 is 20, and 20 minus 2 is 18. So it looks like it's positive 18 equals 0. And then I'm going to subtract 18, and it's negative 6x equals negative 18 divided by negative 6. X equals, negative divided by negative is a positive, so x equals 3. So make sure that on your paper it says 4x minus 1, I think it does, and 10x plus 2. Okie dokie. Hope you guys can see that. So we need to figure out what this angle is here, right? We're questioning this angle. So if I plug 3 in here, 10 times 3 plus 2 equals 32. Sneak that in there. So if this is, let's say 10 right linear times 3 plus 2 equals 32. If this equals 32, in here, this has to be 180 minus 32. So 180 minus 32 equals 1. So 48. So this should equal 148. All right. Again, it's tough because this is 180 minus this here. And so we had to plug in this expression, right, for what we were missing, and then plug it in again. So we could have also checked that. If we plug in 3 in here, it would be 12 minus 1, which equals 11, and this is 21. So 21 and 11 are 32, and 32 plus what equals 180, because the interior angles must equal 180. And so we get 148. All right. Number 10, moving right along. This one came from a worksheet, so you saw it on a worksheet, but we'll also see it again on the test. So we want to make sure that we look at the order of the triangles. So GRL has to match MAN. MAN. An angle M is double angle, must match angle G. GL has a triple line, so it must equal MN, and segment MN with a triple line. And M plus A, so M plus A, so double plus single, right, must equal double plus single. So that would be angle G plus angle R. Okay. This next one, so it looks like, so you can do this a lot of different ways. We can just look at it in here, or you could draw out two triangles, right, if you wanted to. You could draw out triangles. That would be fine. You can go A, C, B, and then X, Y, Z. That's a Z. You want to do it in order though, so I said it was A, C, B. We would also want to go X, Y, Z, not in alphabetical order, so be careful. We can also check it just based on the listing here. So ACB is congruent to YZB. Sorry, YZX. That is not true because it's not the same lettering we have here, right? So this is false. false. B is equal to y. B is not equal to y. B is the last letter or the middle letter, so that doesn't match up. B is not equal to y. B was on the bottom, y was on top, so that's false. BC is equal to zy. Yes, true. XY here is equal to AC. Bingo, that looks good too. And AC is equal to XY. XY. Well, that looks like just a spin on that. So that looks true. Good. Okay, moving on. So to examine his new bow tie for a party, Jacob marked off congruent triangles as shown on the diagram. This is a very serious party. How does he know the lengths of AB? How does he know that this length here is equal to this length here? Ooh, this is a trick. Now, I think a lot of us would look at this and say, oh, no problem, side, side, and they're asking us that these are equal, so side, side, side. No, it is not side, side, side. You want to be very, very careful. We don't know about this third side here. There's nothing telling us that they're equal. We have no idea. So what we need to do is we need to look at this, and we know this is congruent to this because of the marks. This is congruent to this because of the marks. And we know that this angle is congruent to this angle by vertical angles theorem. So that means we are actually showing side, angle, side, right? Side, angle, side. So it's actually side, angle, side. And then by corresponding parts of congruent triangles are congruent. So if these two triangles are congruent, then we can call these their bases must be congruent. What information is needed to prove that MLK, these are my initials, I love it, MLK is congruent to PQR. Okay, so we have to be careful. So it looks like MLK is congruent to PQR, which means that this is congruent to this. These angles are congruent, so they're in a different orientation, and these would hopefully be congruent. So that's what we would need to prove side, angle, side. So side, angle, side, side, angle, side. So we would need to know that KM equals 10. Easy enough. KL, that wouldn't help us. KM, no, that would be the wrong side. KL, okay. Good. All right. Scooch the paper up. Here we go. Triangles EFG and KY. Okay, here we go. So I added in 2 triangles just to make this easier for you guys to see. You do not have this on number 14. You do not need to even draw the triangles, but for teaching purposes, I thought it'd be easier. So this tells us we have triangles EFG. So EFG and XYZ. Again, I want to go in the same order, are given, and we know these are congruent by side, angle, side. Okay. So we have that x, the measure of x, y, z, so this measure up here, this equals 4p plus 10, and they definitely should have put a degree sign up here, but they didn't. That's my degrees. It's an angle, it should be degrees. And then EFG, this right here, is 6p minus 4. Okay? YZ, this side here is 3n minus 6, and GF is n plus 6. And since our triangles are congruent, this becomes a pretty easy problem where I can set both of my congruent angles equal to each other. So 6p minus 4 equals 4p plus 10. Subtract 4p, subtract 4p. I have 2p minus 4 equals 10. Add 4, I get 2p equals 14. And divide by 2, p equals 7. Okay, p equals 7. Oh, that's one of our answers. Bam, right there. Okay. Great, and now I can solve for n. So this side here is equivalent or the same, congruent to the other side. So I have n plus 6 equals 3n minus 6 minus, or subtract the n. I get 6 equals 2n minus 6, add 6, add 6. Make sure you are careful of the signs, add it because it's negative here. I get 2n equals 12, divided by 2, n equals 6. Ooh, n equals 6. That means that n is 1 less than p. So, second answer that's correct. Okay. We're moving now. Oh, I guess I should have also put, this was also degrees. Okay. FG equals 6. Nope. So if I plug 6 in here, FG equals 12. So that's not correct. That equaled 12. X, Z, Y equals 42. How would we know that? We already got P equals 7, N is 1 less than P, N is 6, P is 7. We agree with that. E, F, G equals 35. Does this equal 35? Well, 6 times 7 minus 4. 6 times 7 is 42, minus 4 equals 38. It's an 8. That is not 35. It's 38. And then xy equals 12. xy equals 12. How would we know that? No information about the sides. There's nothing that says this side is equal to this side. This does not say it's an isosceles. I can't mark this true. So just those two in the center. Okay, we are so close to being done. So which of the following rigid motions could map U onto BA? Okay, or YOU onto BEA. So let's make sure. So we're going U to BEA. So I want to make sure that everyone, when you get your test, make sure you know which direction you're going. So we're going this way, down that way. That's my arrow. Okay, a reflection over the y-axis followed by a translation. Okay, so reflect it over the x-axis. So let's see. So we have this, and it would be flipped over and then moved. That looks exactly like what happened. So I'll say yes. A translation, this should be an arrow, of everything by 2 to the right and down 9, followed by a 270-degree rotation around the origin. Okay, so 1, 2, down 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, U lands on A. Okay, so that's 1 point. 1, 2, 1, 2, 3, 4, 5, 6, 7, 8, 9. That would be O prime. This was U prime. And then Y is over 2, down 1, 2, 3, 4, 5, 6, 7, 8, 9 here. So this would be Y prime. This would be our triangle. And then it says followed by 270 degree. No, that didn't work. That would not put us on top here. We would need a reflection over, say, x equals 3. How about, oh wait, reflection over y-axis followed by, that's not a trick question. That's the same as the one above. A rotation about the origin followed by a reflection over y equals x. So a rotation around the origin, okay, where it would rotate on this around the origin, so twist around the origin, followed by a reflection of y equals x. Well, let's see. So this is, say we wanted to reflect it 180 degrees. It would kind of look like that. Kind of. So this is 1, 2. It would be -1, -2. This is -5, up 2. It would be 5, down 2. So here. And then it'd be -4, up 6. So 4, down 6. Here. That would be the triangle. Say if it was 100, it doesn't say, it just says a rotation at the origin, but say it was 180. And then followed by reflection over y equals x, which is y equals x is this way. Oh my goodness. Y equals x is here. That would put it here. No, there's no way. Nope. And then a translation followed by a reflection over a vertical line. Okay. So translation, it was moved somewhere and then reflected. Yes. I agree with that. Because you could have moved it anywhere, right? And then find a reflection. Like we decided we could move it down here even and then reflect it over x equals 3, which is a vertical line. Like this could have been reflected over here, like we talked about before. We could have done this translation followed by a reflection over x equals 3, which was a vertical line. So I agree with that. And then this is a kind of weird one. I want to highlight this. So it says just that we have no motion except that just that YOU equals BEA. And I think that that seems odd, but that is correct because the triangles are they're still congruent, okay? Different orientation, but still congruent. So, all right, last one, yay! So triangle OMG has vertices at -1, -2. I guess I forgot this. Where did I get that? Oh gosh, -3, -2. Okay. OMG has vertices. Okay. OMG is -3, -2. That's my O. M is 5. 1, 2, 3, 4, 5, -1, that's M, and G is 5, -3. Okay, this is my OMG. I'll graph this. Okay, and it says point B. Oh no, we have another typo. G is rotated 90 degrees counterclockwise around the origin, forming G prime. Oh no, to give you OMG, but that's right, OMG prime. So what kind of triangle is OMG prime? Okay, so let's try this again. So point G is rotated 90 degrees counterclockwise. Counterclockwise is this way, around the origin, forming G prime. So where is G prime? Well, if it's at 5, -3, we're going to turn the paper and we're going to go 5, 1, 2, 3, 4, 5, -3, and it's there. Okay, so this is G prime. So we have a new triangle. I'm going to draw the new one in orange. So G, O, I'm still here. I'm still OM, but now I have a new side, which is here. Okay, this is my new triangle. Okay, my old triangle was just a little bitty one here. Okay, so the question is, what kind of triangle is this? Well, there are different ways of doing it, so you should probably test it out, because is it isosceles? Are these two sides the same as this? Well, we know all three sides aren't the same, so clearly it's not an equilateral. Okay, is it scalene? Could be scalene. Is it isosceles? Are these two sides congruent? We don't know. So we could check it really quickly, though. I should be using a ruler. Okay. 1, 2, 3, 4, 5, 6, 7. 7. 1, 2, 3, 4, 5, 6. 6. 7 squared plus 6 squared is 49 plus 36 equals C squared. And 49 plus 36 is 85 equals C squared. So square root. So this side is the square root of 85. And this side here, well, this is going to get messy. I need to make my right triangle. This is A. Let's try brown. 1 by 1, 2, 3, 4, 5, 6, 7, 8. Oi, it's 8. This is 8. This right here is 8 by 1. So 8 squared plus 1 squared equals C squared. 64 plus 1 equals C squared. 65 equals C squared. Square root. That is square root of 65. Okay, So is it square root of 85 same as square root of 65? No. So this must be a scalene triangle. Okay, and that brings me to the end. All I'd like to say is that please read this. Please make sure you know which postulate to use to prove if two triangles are congruent. What do I mean by that? I mean, if you're given two triangles and I said angle, angle, angle is congruent to angle, angle, angle. Is this enough to prove they're congruent? This would be A, A, A. Is that enough? No. A is not a postulate that proves congruence. It proves similarity. So no. But what if I gave you a triangle that looks like this? Can you prove this one? Of course you can. This is side, angle, side. Side, angle, side. This would use SAS to prove that these two triangles are congruent. One last one. Okay, I have angle, angle, side. Angle, angle, side. Angle, angle, side. Is that a postulate we use to prove congruency? Yes. Bingo! And please make sure you look over and study all of your proofs. The proof was not given on the review because we want you to study your proofs from your workbook and from your worksheets. If you have any questions, please send me an email at clarm@duvalschools.edu. Otherwise, have a great